China is building a base on the moon. Right now, work is already underway to establish what would become the first permanent human outpost beyond Earth. The effort begins with robots. We've already seen multiple Chinese robotic missions on the lunar surface, but this is only the first stage of a much larger plan, one that ultimately involves people living both on the moon's surface and beneath it. That said, the moon is an extremely hostile place. Even landing safely remains a major technical challenge. The greatest difficulties come from the lunar environment itself. The moon has no atmosphere, which means no air and no natural insulation from the sun. When sunlight hits the surface, temperatures can rise above 120 degrees Celsius. When night falls, they plunge below minus 130 degrees. Because the moon rotates far more slowly than Earth, each location experiences about 14 days of daylight, followed by 14 days of darkness. Beyond temperature, there's another unfamiliar threat: cosmic radiation. On Earth, we're protected by a powerful magnetic field generated by molten metal flowing inside our planet's core. The moon has no such magnetic shield. As a result, radiation from the sun and deep space constantly bombards the surface. If humans are going to live there, they'll need a serious barrier against these deadly rays, and a simple metal wall won't be enough. Meteorites pose another danger. When you look at the moon's surface, you see craters everywhere. Those craters were created by rocks from space, and the process is ongoing. Earth is struck by meteorites too, but our atmosphere burns most of them up before they reach the ground. The moon has no such protection. All of this makes sustaining life on the moon incredibly difficult. Yes, American astronauts visited the moon decades ago, but those missions lasted only a few days at a time. What's being envisioned now is long-term habitation, eventually leading to a permanent human presence. China has already begun preparing for that future. In 2019, for example, the Chang'e 4 mission carried a sealed biosphere experiment known as the Lunar microecosystem. Inside were plant seeds, including cotton and potatoes, along with fruit fly eggs and yeast. The goal was to see whether life could survive when supplied with air, water, and nutrients in the moon's low-gravity, high-radiation environment. At first, the results were promising. Cotton seeds sprouted, producing the first new plant growth ever recorded on the moon. But the success didn't last. Within days, extreme temperature swings killed everything inside the container. The experiment reinforced just how unforgiving the lunar environment really is, and why China is relying so heavily on robotic missions to prepare the way for humans. China's lunar strategy can be broken down into 3 phases: reconnaissance, construction, and habitation. Right now, the program is roughly halfway through Phase 1. That's the purpose of the Chang'e lander missions. There are several ways to build a lunar base. The most obvious approach is to construct everything on Earth, launch it into space, and land it on the moon. Simple in theory, but incredibly difficult, risky, and expensive. A more practical option is to use materials already available on the moon, a strategy known as in-situ resource utilization. That's where China is focusing its efforts. A future mission, Chang'e 8, scheduled for launch in 2028, will test an experiment designed to turn lunar soil into construction bricks. In this process, autonomous robots collect lunar soil and compress it into molds. The molds are then heated at high temperatures, forming bricks in various shapes: rectangles, cubes, and arches. Other robots stack the bricks and apply mortar to create low-profile structures. The same material can also be used to build roads and landing pads. These thick stone structures provide excellent protection from radiation and meteor impacts, as well as insulation against extreme temperature changes. However, they have a major drawback. They're not well suited for holding internal air pressure. Since the Moon has no atmosphere, habitats must be pressurized. Rectangular shapes with sharp edges lack the structural strength needed for that, unlike round forms such as water towers or propane tanks. As a result, any brick structure would still require a pressurized internal shell. That's why China is also exploring a more advanced concept, a fully 3D printed habitat known as the Moon Pot vessel. Lunar soil can't be 3D printed on its own. It must be mixed with an adhesive, which would need to be transported from Earth. Even so, the design offers significant advantages. Before printing begins, robots lay down a thick foundation made from processed lunar soil to absorb vibrations from moonquakes, which occur regularly. To print the structure, lunar soil is heated until it melts, mixed with adhesive, and deposited in circular layers. The resulting shape mimics the natural strength of an eggshell and consists of 3 layers: an outer shell, an inner shell, and a triangular rib structure in between. This design can hold pressure without additional internal lining, while still providing strong radiation shielding and insulation. 3D printing also allows for taller structures, which makes sense on the Moon. Lower gravity makes vertical movement easier, and without wind or weather, structural stability is less of a concern. All of these plans depend on solving one critical challenge: energy. Whether it's baking lunar soil, powering 3D printers, or keeping systems running, a moon base will need a reliable power source. China's solution is nuclear energy. In 2025, China and Russia announced a partnership to build a nuclear power plant on the Moon. This isn't especially surprising. While Russia's recent lunar missions have struggled, such as the failed Luna 25 lander in 2023, the country remains a global leader in nuclear technology. Rosatom, Russia's state-owned nuclear company, is the world's largest supplier of nuclear reactors and enriched uranium, exporting reactors to countries across Europe, Asia, and the Middle East. It has even built a floating nuclear power plant in the Arctic. On the Moon, nuclear power actually makes a lot of sense. Cooling a reactor is easier in an environment with no atmosphere. Shaded regions, such as deep craters near the lunar South Pole, remain extremely cold, making overheating less of a concern. As for nuclear waste, the Moon is already exposed to intense radiation, so disposal poses fewer environmental risks than on Earth. If surface construction succeeds, China plans to go even further by moving underground. The Moon contains vast lava tubes formed by ancient volcanic activity. Some have collapsed ceilings, revealing massive underground caverns. These lava tubes offer natural protection from meteor impacts, radiation, and extreme temperature swings, making them ideal locations for long-term habitation. China plans to investigate these structures during its robotic exploration phase. The Chang'e 7 mission, launching in 2026, will carry ground-penetrating radar to map the lunar subsurface near the South Pole and identify potential lava tubes. Construction of China's moon base is expected to begin in the 2030s. The initial site will be fully robotic, located near the lunar South Pole, where resources are most abundant. Humans won't arrive until systems are proven safe and operational. Between 2031 and 2035, China has scheduled 5 major lunar landings. Each will deliver a different component of the base: command and power systems, research facilities, resource processing technology, robotic exploration units, and finally, lunar astronomy and Earth observation infrastructure. That timeline puts Chinese astronauts living on the Moon by the end of the next decade. While China may attempt a crewed landing sooner to demonstrate capability, the focus is clearly on permanent habitation. not short visits like the Apollo missions. And of course, China isn't alone. The United States has its own ambitious lunar plans. Competition for space on the moon is coming, and that's what we'll explore next time. So, stay tuned.